So the exponential rule from yesterday. The rule itself is a very simple and very, I mean, we like this kind of rule because the derivative of e to the x is e to the x itself. I mean, this is so simple. Cannot get any simpler than that when it comes to differentiating rules. But here's what we're going to do next. Next, I'm going to, what happened here? I want to prove the exponential rule. So here comes the proof. The proof itself is very simple, but what I'm going to do, I'm going to use it to introduce a definition. So let's look at the proof. Any derivative f prime, the definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x. All of it divided by h. Okay, this is our starting point. In particular, when the function is e to the x, then we're going to say that d dx of e to the x is the limit as h goes to 0 of e to the x plus h. Remember, every time we see x, we replace it with x plus h, minus e to the x divided by h. Okay? And the next thing I'll do a little simplification here. Well, I'm not sure. It's actually expansion. What is e to the x plus h? Well, it's the same as e to the x times e to the h, right? Because when you multiply two exponents that have the same base, you add the exponent, you add the powers. So it will be the limit of e to the x times e to the h minus e to the x divided by h. And then we can factor e to the x. So let's write it here, e to the x, and what we have left is e to the h minus 1 divided by h. Okay? Now, look at this expression right here. Let's put it in parentheses because I'm very interested in this quantity in the parentheses. But does e to the x change when h approaches 0? Anybody venture to answer? X is not a variable when it comes to the limit. What the variable of the limit is h. H approaches 0. What we change closer and closer to 0 is h. As far as the limit is concerned, x stays the same, some kind of constant. Since e to the x doesn't participate in the limit, we can pull it out. We can factor it outside the limit. Okay? And it will be e to the x times the limit as h approaches 0 of this quantity, e to the h minus 1 divided by h. Okay, and here I need to pause, and I want to introduce you to a definition of the natural number e. There are, in this course, I'm going to teach you 3 definitions of the natural number e, which is a very important number in nature and in science. Similar to pi, for instance, if you look at a tree swaying in the wind, the amplitude, the distance that the top of the tree is moving from the neutral position is a function involved e, right? If you put a a bacteria in a petri dish and let it multiply, let it grow, well, the E is part of the growth function of this bacteria. Actually, E is involved in any population growth function. If you leave the lights in the car on and you turn off the engine and you don't have this gadget that alert you that the lights are on, what happens is over time the battery will drain. If you look at the function, the voltage in the battery itself over time, well, this function is described by E. If I take a rubber band or I play a guitar, can you hold this end of the rubber band? Okay? And don't let go. And I let it go. Did you see how the rubber band attenuated until it went back to the neutral position? Well, that amplitude, again, described by the number E, the amplitude itself. So, in music, in electricity, in construction, you have a bridge. You have you take two support and you place a beam on top of it. And when you stand on the beam bent downwards, right? The bending, how much the beam was went down, has E in it. So E is everywhere. The great designer of nature designed the number E to express all these phenomena. The same as pi. Pi is who to know that pi will be a constant, a ratio of the circumference divided by the diameter. So here's the definition of the number E. Okay. So I want to say that the number E is a number that makes the following limit equal to 1. Equals 1. Okay, what is the following limit? It will be the limit is h approaches 0 of a box here to the power of h minus 1 divided by h. Okay? If you take all kind of numbers and you check the limit as h goes to 0, and you can start by taking, 1 and then 2 and then 3, and you want this to equal 1, you want this limit to equal 1, then turn out the number that will do the trick for you will be the number E. If you stick E in there, don't know if you can see it, then that will be. So here's its indirect definition of the number E, or you can say that indirect definition. The limit of e to the h minus 1 over h as h goes to 0 equals 1. Later on in the semester I'll show you another definition and another variation of that definition where it will be explicit. In other words, E is so and so. Okay? But this is indirect definition.